Welcome to A-Level and AP Physics. In today's lesson, we will discuss an important past paper question on capacitance from March 2022, Paper 4, Variant 2. This question is based on new specifications and very important for our coming exam. For question number 5, the variation with potential difference V of the charge Q on one of the plates of a capacitor is shown in figure 5.1. As you can see here, we have charge Q on y-axis and potential difference across plates is on x-axis. It is also given to us the capacitor is connected to 8-volt power supply and two resistors R and S as shown in figure 5.2. So in this case, you can see capacitor is connected here. This is symbol for capacitor and this is symbol for power supply. This is 8 volts power supply. Resistor R is connected here at this point and resistor S is connected here. And this is our switch, two-way switch. This switch can be moved to X. This can also be moved to Y. When this switch is at position X, this capacitor is charging. Very important point, we need to understand when the capacitor is charging and when the capacitor is discharging. In this case, capacitor is charging because there is power supply in this loop, or simply you can say in this circuit. But if we move this switch to Y, this capacitor will start discharging because in this loop there is no any power supply. There is only resistor. So capacitor is at higher potential, it will start discharging. So very important point we need to understand about charging and discharging. Now let's move on to part A and try to answer part A. For part A, question is asking us, the switch is in position X so that the capacitor is fully charged. We need to calculate energy E stored in the capacitor. In E energy stored in the capacitor we need to calculate. So energy stored in a capacitor is equal to 1/2 QV, or we can say this is 1/2 CV square. Our energy stored in a capacitor is 1/2 Q square over C. But if you look at this graph, in this case we have value of V and we have value of Q. So simply we can use E is equal to 1/2 QV and we can find out energy stored in the capacitor. Now let's try to understand what value of Q we have to use and what value of V we have to use to calculate energy stored in the capacitor. So the first thing we need to understand is the voltage of the battery, means the voltage of this battery is equal to 8 volt. So when this capacitor is fully charged, means when there is no current flowing in this circuit, at that time the potential difference across the battery and the potential difference across the capacitor, these two potential difference they will be same. So this is capacitor. So the potential difference across the capacitor, when this is equal to potential difference across terminals of the battery, current flowing will stop. So in this case, battery voltage is 8 volts. So the capacitor voltage also will be 8 volt when this is fully charged. So this is the key concept you need to understand. In this graph, you can see this is the 8 and this is the value of potential difference across capacitor when this is fully charged. So we have value of V and the value of Q is 1.2. So simply you can say you just need to calculate area under this line. So now we can plug in values. We have 1/2 and value of Q is 1.2 times 10 to negative 4 and we need to multiply with value of V, that is 8 volts. So our final answer in this case will be 4.8 times 10 to negative 4 joules up to 2 SF. So this is our final answer for E. This question has 2 marks. You will get first mark if you have used this formula or you have written area under graph. You will get C mark. And the final mark is the answer mark. If you have got right answer, you will get answer mark. So the tricky point, this is the most important point. You need to understand when the capacitor is fully charged, the potential difference across the capacitor can be equal to the potential difference across terminals of power supply. Terminals of power supply. So very important. For part B, it is given to us the switch is now moved to position Y. Means when capacitor is fully charged, we move this switch to position Y. When we move to position Y, this capacitor will start discharging. So simply we can write down now capacitor is discharging. And question is asking us, we need to show that the time constant of the discharge circuit is 3.3 seconds. So how we can calculate time constant? Time constant, we use letter tau for time constant tau, and this is equal to RC. And this R actually is very important. This is resistance of discharging circuit. The resistance of, we can say this is resistance of discharging circuit. Also you can say discharge circuit. Resistance of discharge circuit. Very important point. So in this case, the discharge circuit has a resistance equal to 220 kilo ohms. So simply we can use here R is equal to 220 kilo ohms. So this is value of R. Now we need to calculate value of C as well. But Q is equal to CV. Simply we can say C is equal to Q over V. C is equal to the charge on one plate of the capacitor divided by potential difference between the plates. So when the charge on one plate of the capacitor is this one, the potential difference across two plates, that is equal to 8 volts. So we can say in this case the capacitance, this will be equal to 1.2 times 10 to negative 4 divided by 8. So this one is capacitance 8.0. Now simply we can plug in value of C and we can calculate tau. So value of C is 1.2 times 10 to negative 4 divided by 8.0. So our final answer in this case is 3.3 seconds up to 2SF. Because this data has 2SF, this also has 2SF. So least number of SF we have 2. So we can say 2SF. And this is our final answer. This question has 2 marks. The first mark you will get if you have used this formula. And the second mark you will get if you have got the right answer. For the second part, it is given to us the fully charged capacitor in A stores energy E. We need to determine the time taken for the stored energy to decrease from E to E by 9. So this question is simply about the relationship between energy and time. But we don't have any direct formula or equation that link energy and time. But we have equations for discharging. We have V as a function of time, means we can find value of V at any given time, mean the potential difference across plates of capacitor by using this formula. And this is the V max, maximum value of potential difference, times E to the power of T over RC, and this is the time constant. We can also use Q as a function of time. This is equal to Q initial value or Q max, we can say, times E to the power of T over RC, and T is the time taken. We also have relationship for I as a function of time. This is also equal to I naught, maximum value of I, times E to the power of negative T over RC. We can use them and we can find the value of time. But if we have value of T, then energy, means if we have value of V, when energy becomes E by 9. So first of all, we need to find out value of V. Or we can find value of Q, or we can find value of Y. But in this case, it is easy to find value of V. So we will just focus on V. So we will find out value of V when energy stored in the capacitor is E by 9. So let's start to find out value of V. So we will start from here. Energy stored in a capacitor, let's say this is E naught, this will be equal to 1/2 C V naught square. But in this case, we can write down E naught over V naught square. This will be equal to 1/2 C. The capacitance of capacitor is constant. So simply we can say this will be equal to some constant. We can say that E naught over V naught square, means the ratio between these two quantities will stay constant. So let's say we have the new energy stored, that is E new. We have to find out what is new value of V. Now from here we can find out value of E nu as it is given to us. E nu is equal to E naught by 9. So we'll write down here E nu is equal to E naught by 9. From here we can rearrange, we can write down V nu. This will be equal to E nu times V naught square divided by E naught. E nu is E naught by 9, so this is value of E nu, and we have V naught square, and this is divided by E naught. Now from here you can see we can cancel E with E, so E we can cancel with E, so we left with V naught square divided by 9. Simply we can say V nu, if we take square root on both sides, we will get this is V naught by 3, and that is the value of V nu. And now we can use value of V nu, and we can use this equation, and we can find out value of T. Now let's try to find out value of T using the formula V as a function of time. This is equal to V max times e to the power of T over RC. Or we can simply say this is equal to V naught e to the power of negative T over tau, and tau is time constant. Value of tau we have already calculated, so we can plug in value of tau. Tau is 3.3 seconds. Now value of V nu, we can rewrite this formula. So V nu, this is equal to V naught e to the power of T over tau. V nu we have calculated, this is V naught by 3, and this is equal to V naught e to the power of negative T over 3.3. So V naught we can cancel, we simply left with 1 over 3. This is equal to e to the power of negative T over 3.3. If we take natural log on both sides, we can say this is 3 to the power of negative 1 e to the power of negative T over 3.3. Now if we simplify this log, we can say this is negative come in front of log, so this is ln of 3, this is equal to negative T over 3.3, because ln of E is 1. So let me write on here ln of E, this is equal to 1. So this negative we can cancel with negative. So T from here is simply equal to ln of 3 multiplied with tau, and our final answer in this case will be 3.6 seconds up to 2 SI. So if you have done this working, you will get 4 marks for this question. The first mark is if you have used the relationship E is equal to 1/2 CV square, you will get 1 mark. So this is 1 mark, and this is C 1 mark. And the second mark you will get if you have got the relationship that V nu, this is equal to V naught by 3. So this is an other C mark you will get. And the third C mark you will get if you have used this formula. So if you have used this one, you will get the third C mark. And the fourth mark you will get if you have got the right answer. So this is how you will get these 4 marks. And this question is very important because this is based on new syllabus. Maybe you will see this question in May-June exam as well. Maybe they ask you in a little bit different way, but this concept maybe will appear in coming exam. So try to understand this one and try to master this concept. For part C, it is given to us a second identical capacitor is connected in parallel with the first capacitor. So it simply means that there is another capacitor that is identical to the first one and is connected in parallel with first capacitor. So this is how new capacitor is connected. And question is asking us state and explain the change, if any, to the time constant of the discharge cycle. So the first thing we need to understand is now in this case when the capacitors are connected in parallel, and if two capacitors they are identical, so it simply means that the capacitance is simply double. So you can also imagine like that if we combine these two plates, you see area of the plates increase, but the distance between plates is the same. So it simply means that capacitance is double because capacitors are connected in parallel. So we can say capacitance is double. So this is the first point we need to understand. Now the second thing we need to explain is time means the tau. Tau is equal to RC. If the C is double, so it means tau is also double because resistance of discharge circuit remains constant. So it means tau is also double. So that's all what we need to write on 2 points, and this question has 2 marks. Let me show you the answer. This is how you can write down the answer. First mark is M mark, means you must get this mark to get the second mark. So if you have written capacitance is double, you will get 1 mark, and that is a M mark. And the second mark you will get if you have written time constant is also double. If you simply write down time constant is double, but you haven't written first point, you will get no mark. So you have to write down first of all capacitance is doubled, then you can say time constant is doubled because capacitance is doubled.